Proofs. So up until now, we've verified. We've never proven. We verified that the left side equaled the right side, but we verified that it equaled the left side equaled the right side for that one value, right? A proof proves that for every single value of x or theta or whatever the variable is, it works. So you're never going to be able to plug something in for x. Yeah, we're not using that right now, though. We're going to do that on Monday. You're just writing notes. Okay. So we're going to prove that 1 minus sine squared x equals, and this is where it gets fun, sine x, cos x, cotan x. The key is to not get overwhelmed by what it looks like. This actually is a very easy proof. Like, no, it is. It's like 2 steps. That's it. People who are good at proofs are the people who know what's on their formula sheet. I've said that before, right? Now, when we did verification, you'd plug in 60 degrees for each of these x's and you'd show left side equal to right side. But that only proved that it worked for one example. And if you even showed me 100 examples that worked, that would be great. But that would only show that it worked for 100 examples. It wouldn't be a proof to show that it works for every example. So the only way that you can prove something is by not filling anything in for the x, subbing in different formulas to get left side to equal right side. So like sine x equals sine x ultimately at the end or something like that. So when you're proving, you have to remember what's on your formula sheet. This pops up a lot. If you have 1 with cos squared or 1 with sine squared, this Pythagorean theorem identity comes up a lot. Remember that it can be rearranged, right? So sine squared can be replaced with 1 minus cos squared. Cos squared can be replaced with 1 minus sine squared. Secant squared can be replaced with tan squared, secant squared minus 1. Cosecant squared can be replaced with 1 plus cotan squared. Cotan squared can be replaced with cosecant minus 1. Like all of these can be rearranged, okay? So I always look for the Pythagorean theorem identities first and see if I can cross any of those out. And then what I also do for proofs is anything that's not cos or sine, that's like singular, like secant or cosecant or cotan or tan, I change to coses and sines. Their version of cos and sine. So 1 minus sine squared, if you look up there, and I move the sine squared over on the Pythagorean theorem identity, the very top one, sine squared plus cos squared equals 1. I'm going to be able to replace 1 minus sine squared with cos squared, correct? So this whole thing gets replaced with cos squared x. The way people get better at proofs is by doing a whole bunch of them. That's the only way you get better at proofs, because then your brain starts thinking about, hey, when I see this, I do this. When I see this, I do this. And it's not like you have to stare at it for a while and be like, and then stare at your formula sheet for a while and be like, is there anything I can do here? And you get a little sad. Okay, we don't want that. We want to practice these. So sine x, there's nothing I can do with it. So it stays sine x. The catch with proofs, you guys, is whatever's on the left has to stay on the left. Whatever's on the right has to stay on the right. So I can't like say, hey, I want that cotan to move over, or hey, I want that cos to move over. So I divide by cos and move it over. You can't do that. What's on the left has to stay on the left. What's on the right has to stay on the right. And it's like there's a fence down the middle. So I always draw myself a little line down here, and nothing can cross that fence. Nothing from the left can go to the right. Nothing from the right can go to the left. Okay? So I have sine x, and it's multiplied by cos x. I'm going to put it in brackets so that I know that. And then cotan is what?
Cos over. Jinx.
Then what can I do? So I have, and then that's exactly what happens. When you're doing proofs, honestly, while you're doing the proof, you're kind of like, the whole time you're like, hope this is going well. And then all of a sudden, before you even write the last answer, you can see that it's going to work out. And you're like, yes! Like you're just so excited before you even write the last answer because you can see that it's going to work out. And if it doesn't work out, if you can't get a proof to work out, The best thing to do would be to start over on another sheet of paper. It's not to try and decipher through maybe what you could have changed and what you could have done along the way. You'll never catch an error. You'll never figure it out. It's better to just start over fresh and see if you can figure out a new way to go through it. Not try and work through your old way and see if you can figure something out. Yep. Yep. Okay. V.
Can we try this one by ourselves?
The diploma has someone, it's attached in the back. No, it's a few. Yeah. They have a graphing paper one, like a like not Cartesian planes, but graphing paper. They have one of those. If ever you need extra, the people who are supervising you always have extra at the back. They're diploma ones that you have to like insert in after, but they have extra paper for any of your diplomas. People in English ask for them all the time. Well, they don't want it leaving the room, right? Because it's diploma stuff, so they want it inserted in because they don't want you to be able to walk out with it or even be in a garbage can and someone take it with them. I'm recording all of that. Okay.
Try this one by ourselves.
Yes, you can.
Sorry, classes.
That's what was going to happen anyways. So the 1 minus cos squared can be written as what?
Sine squared.
Yeah. This is my hint to you. The moment your top becomes a fraction, your numerator over here becomes a fraction, or your denominator becomes a fraction, write them out side by side. Don't write them as fraction over like fraction. It's like creepy, weird looking. It's hard, and you're going to have to flip it and multiply. It's just substantially easier if when you get fraction over fraction, you write them side by side instantly. So on the top here, I'll show you what I mean. You're going to get sine x over cos x. And yes, you'll see the cos x goes away, and that's fine. But on the bottom, you're going to get 1 over sine x. And this looks terrible. To me, it does anyways. And how are you going to flip that and multiply it when it's underneath, right? So the moment there's a partial fraction on either the numerator or the denominator of a fraction, okay, write them side by side. So I'm going to write this. So I'll cross my cos x's off, sure. And I'm going to get sine x divided by 1 minus 1 over sine x. And actually, I would have never written this step out like this. I would have written this step out as this divided by that. I would never write fraction over fraction. It just gets super confusing, and people make oopsies. Okay? So the moment you can tell that your top or the bottom is turning into a fraction, I start writing them out sideways. Equals sine squared x. Division, you multiply, so you're going to get sine x times sine x over 1. And then you get sine squared x equals sine squared x. Now, do you always have to change the left side and the right side? No. What it might be like this whole really awful looking thing equal to sine x. You may never change one side. You may only choose to change the other side. You may change one side for a while, the more difficult looking side, and then be stuck and be like, okay, maybe I'm going to start trying to change this side. So you don't always have to be changing both sides at the same time. Okay, try this one. C.
I like it when we try them ourselves and then see if we get it.
That's what you do with proofs. Tan x equals
Hey, that's nice.
1 minus cos 2x over sine 2x. So this one, tan x is sine x over cos x. And I would try and change everything to sines and coses if possible. 1 minus 2 sine x, so I'm going to do the sine 2x first because it only has one option. It's 2 sine x cos x. I know that I'm going to need to get rid of the 2 and the sine x off this denominator, so I have just a cos x like this one, correct? So the only way that's going to happen is if I can get a 2 out of here somehow. I have this 1 here that's sitting here that I want to go away, right? Because it's not very helpful to me at this point. So I'm going to try, I know that very much so that the very top one is a bad decision. I know that the bottom 2 cos 2x's might be a good decision. So if you try one and it doesn't work, try the other one. But I do know that the top one, very, very bad decision. So I'm going to try, which one do we want to try? The bottom one? But why would we want to try the bottom one? Then the ones won't go away.
Oh, yeah, that's not a good idea. Let's try.
Is it not a good idea?
It is a good idea.
It,
So
yeah,
I missed that. Nice. Okay, those kind of. Because I got stuck.
because everyone picks the middle one because when just they pick the middle one because they're going to go 1 and they're like -1, yay, right? But you're actually minusing everything that you put in there, right? So that's why we actually pick the bottom one, which is 1 minus bracket 1 minus 2 sine squared x. You are actually subtracting the whole thing, and then you're actually subtracting it. So that's why you pick the third one.
So the ones cancel, you're saying?
Yes. But if we picked the other version, which had the -1, which we would have done before, right? It would actually be minus a minus, which would be plus. Now, this is where people error. They forget to put this whole thing in brackets. Anything behind a subtraction sign has to go in brackets, right? So this is going to be subtraction 1, and we're going to add the 2 sine squared. And then this will go away. We just distributed it in. Distributed it. That's some really good words. So then you get sine x over cos x equals 1 minus 1, so they cancel. And then you have a positive 2 sine squared x over 2 sine x cos x. That cancels that. Oops, got a little cancel happy. The sign should still be there. The 2 should be gone. So you're going to get sine x over cos x equals sine x over cos x. Had you not changed the tan x to sine x over cos x, and you kept the tan x the whole way along, you'd get sine x over cos x, and you could just go tan x equals tan x. That would still work, right? It would still prove it's right. That's absolutely fine. I just personally like changing stuff to sines and coses. Okay, I'm going to give you a few questions to try for homework, and then we're going to do the other 2. So these are going to be your questions to try. They're going to be out of different parts of homework, just so you know. So the first one you're going to try, so you're going to write these down. Yeah. Page 296, number 3, and 4. Like I said, they're going to be throughout different ones because you're going to practice. Then page 314, 314, you're going to do 1 and 2 and 10. But I want you to do 10A. Sorry, you should do 7 and 8 as well. So it should be 1 and 2, 7, 8, 10A. And then the other ones you can attempt, but I haven't shown you what to do if you have like a 1 plus cos x by itself or a 1 plus or 1 minus sine x, or how to do the common denominator thing. So you can try them, but I would suggest you probably wait till Monday so you don't get them wrong.